Hello and welcome back to Calculus. First, I'd like to thank all the nice people that support this channel by liking and subscribing. Today, continuing the previous video, we will speak about areas between curves, so let's immediately visualize this. Let's say we have two functions here, f and g, and we're tasked with finding the area between them, specifically this part right here. The first thing we have to do is establish the boundaries, specifically where the two functions intersect. Let's say we call the lower bound a and the upper bound b. Next, the idea is to subtract the bigger area, specifically this blue part right here, and minus out the smaller part, the smaller area, specifically this green part right here. And what you're gonna have left is everything in the middle. The red area, which is exactly what we need to find. So now that means we need to construct two integrals. We take the integral from our bounds a to b of the upper function f of x, and then we take the same integral from a to b of the other function g of x. And finally, we take the bigger area and subtract the smaller one. And of course, without a doubt, the result you're going to get is going to be a real number. However, this integral right here, this expression can be simplified. As you know from rules of integration, if the integrals have the same bounds, we can put them under the same integral. So what happens here, we take one whole integral of one function f of x subtracted by the other function g of x. And the result you're going to get should be the same as this one. This seems pretty straightforward, so let's take a look at a different case that can also happen. Here, once again, we have two functions f and g. They intersect and they form two parts of areas, one on the left-hand side and the other on the right-hand side. Of course, once again, the first step that we do have to take is find their intersections in order to establish the bounds of our integral. However, as you can see in the first part of our area, the function g is above and the function f is below. So that means we can construct an integral from a to 0 of the function g minus f. However, from 0 to b, we see that the functions interchange positions. From 0 to b, the function f now is above and the function g is below. So that means we can construct an integral from 0 to b of the function f minus g. However, there is an alternative that does exist. You can construct one integral from a all the way until b, but then we have to take advantage of the absolute value brackets. Now that means no area we get is going to be negative and everything is going to be added up. If you do not put the absolute value brackets, you might have the thing that the first part of the area is positive. However, when you come to the next part where f is on top, the area is going to be negative. So please pay close attention. You can either write it as two different integrals or you can put the absolute value signs. Then it doesn't really matter if it's g minus f or f minus g. However, there is a third case that also exists that I would like to show you. Let's say we have two functions f and g as such, and we're tasked with evaluating the area under the curves bounded by the x-axis from 0 to b. So that means this whole area right here. Well, now here comes the problem. One part of the area is bounded by one function and the x-axis. The other part of the area is bounded by another function and the x-axis. Here would be a colored visualization. So that means, once again, the first step we have to take is find the intersection of these two functions, and we call it A. Unfortunately, here we do not have a choice but to construct two definite integrals. One integral is going to be from 0 until a of the function g, and of course the other integral is going to be from a to b of the other function f of x. Once you compute these two integrals, you add up the results, and what you're going to get is once again a real number which represents the area. For now, I will conclude the theory here, and in the next video, I will show you examples for each case that we have analyzed today. So I hope to see you there, and have a nice day. Bye!